gonna share my screen here in a second. Okay, well, again, welcome. I'm Eric Admin with Sno-King Watershed Council, and this evening we're going to be talking about stream biomonitoring and BIBI, and we'll explain what that is. Our agenda this evening, an overview of those processes. We'll learn about benthic macroinvertebrates, what they are, why they're good for monitoring stream health. We'll learn about the techniques for doing global water watch stream biomonitoring. Learn what is BIBI, how do you do it, and we'll talk about some upcoming training dates. So first of all, just to give a little background, so we are Sno-King Water Watchers, and we're a local program that started in 2015. We collect data on local streams, rivers, and lakes, and we try to cultivate watershed stewardship, provide environmental education, increase public awareness, and work with agencies when we find problems. We are part of Global Water Watch, and that's where we got our stream biomonitoring curriculum. And Global Water Watch is an international organization. They're based nationally out of Auburn University, and they have come up with the curriculum for the stream biomonitoring that we use. So what is stream biomonitoring? As I mentioned, it's a method that's taught by Global Water Watch, and it's using benthic macroinvertebrates to evaluate the health of streams. So benthic means it lives in the bottom of the body of water, at the bottom of a stream. And macroinvertebrates are animals without backbones, but they're invertebrates. They don't have a backbone, but they're macro, so they're big enough that you can see them. And they include a variety of types of creatures. And the reason why they're good indicators of stream health is because they have variable levels of tolerance to water pollution. So BIBI stands for Benthic Index of Biotic Integrity, and it is a quantitative method as opposed to stream biomonitoring is a little more of what we call a qualitative method. So you get a sense of kind of fair, good, excellent, but you can't assign well, you do come up with an index, but it's less definitive than the BIBI technique, where in BIBI, you collect the organisms and you send them to a lab, and then they look at them under a microscope, and then they assess the numbers and types of different organisms and come up with a specific score. And we'll get into that in more detail as well. There's a website if you want to look up more information about BIBI. It's PugetSoundStreamBenthos.org. So let's talk about macroinvertebrates. So there's a number of reasons why they're good indicators. One is that they're very easy to collect and they're pretty easy to identify. You can find a lot of them, and when we do the stream biomonitoring, you'll be amazed at how many we typically find. They typically spend their lives in the same little stretch of creek. They don't go very far. So if you want to look at what's going on in a particular stretch, they're good for doing that. They live for a long time. And in fact, they spend most of their life in their aquatic form. Some of them, though, have other forms that they take besides their aquatic form. And the main thing is that they're different in sensitivity to pollution. So this is a page out of the Streamkeeper's Field Guide. And this just kind of shows you some of the different types of things that are classified under benthic macroinvertebrates. So you've got things that are kind of like worms, such as leeches and segmented worms. You've got things with exoskeletons, sort of in the family of like crayfish and crabs. So you've got a number of things that fall under that. You got some that are insects, and so we'll find a lot of mayflies, stoneflies, caddisflies, black flies, midges. We find a lot of those. And then we also find some snails and some clams and sometimes some mussels. They fall into a number of different groups, and you can identify them down to a more detailed level than this. Like, for instance, under caddisflies, caddisfly is listed as an order. There's actually a lot of different types of caddisflies. And we do identify a couple different types of caddisflies, but we typically don't get down to the very species level. We're at a higher level than that we're identifying. It is helpful when you're trying to identify them to kind of know the names of the different parts of your typical one. So they pretty much all have a head. They have a thorax, sort of their body. They may have wings. They may have gills. They have an abdomen. They have legs, depending on the creature. And they have tails. And the tails in particular is like for mayflies versus stoneflies is one of the ways that helps us identify what's what. And they go through some different life cycles. So some of them go through what's called incomplete metamorphosis, and others go through complete, which basically just means they have a little bit more stages that they go through if they go through the incomplete. Um, Typically, we're finding them at the larval stage, which is where they spend most of their life in the creek. But then the ones that turn into flying insects, we may find that we don't identify those flying insects, but you may see them around, and they typically spend just a very short amount of their life in the flying insect form. They're also organized by their feeding group, which is kind of like what part of the food chain that they occupy. So essentially, one way you can think about a lot of these is that they take like leaf litter and other things that fall into the stream, and they break it down and they use it for themselves. And then they, in turn, are food for other things, which could be other benthic macroinvertebrates, or in particular, could be fish. So these are kind of a key part of the food chain for salmonids in particular. Um, so you don't have to worry about grouping them yourself in terms of the identifying what they are, but it's just useful to know that they do kind of fit into different parts of the food chain. And depending on where you are in the stream, if you're closer to the headwaters or closer to the mouth, you may find more or less of different types of these. So looking at the stream characteristic, there's different areas within the stream that you might find certain of these. So some of these might be clinging to a rock. Some of these might be burrowed into the bottom. Some of these might be on the surface. And then we also look at where are they within the stream. So typically, you're going to find the most of them in a riffle. So a run is that area of smooth water. Riffle is where it's kind of got some texture to it as it's flowing rapidly down a gradient and over some rocks maybe. And then a pool is where it just makes a big slow, shallow, or could be deep, but a big slow area. So typically we're sampling in a riffle, but we sometimes do sample in other habitats as well. Um, Pollution tolerance, as I mentioned, we're concerned, or we find these useful to us because they have different levels of pollution tolerance. And so Global Water Watch uses a three-step grouping, or three different groups for identifying what's less tolerant to what's more tolerant. So group one would be the least pollution tolerant. And these are some of the things that we would hope to find more of in the creek that are indicators of better water quality and less pollution. So then there's some that are considered to be moderately pollution tolerant, so they can tolerate a little bit more of the pollution, but they're still not highly pollution tolerant. And these are examples of those. And then these would be the most pollution tolerant. So if all you found was midges and worms and leeches, that would tell you that maybe there's more water pollution. Okay, let's talk about the equipment that you need. So there's kind of a list of a bunch of different basic stuff that you'll use when you go out and do monitoring. So, and we'll walk through each of these different things, but essentially you need a way to collect the creatures. You need something to put them in while you're identifying them. You need something to kind of be able to separate them out, which would be the pipettes, the spoons, and the tweezers. You need some guides to help you identify what they are. And you need magnifying glasses, especially if you don't have anybody under the age of 50 in your volunteer group. You need sorting sheets, tables, and something to record your information on. There's a couple types of nets that we typically use. One's called a D net because the mouth opening of the net looks like the letter D. So it has a flat section that you would put down on the bottom of the stream. And then you'd use some method of disturbing the bottom to just right in front of the net to get those creatures to float into the net. What's called a kick net, or also known as a seine, is another type of net where typically it's a larger net. Both these nets have like a 500 micron opening, and you would anchor down, you'd spread that net out in the creek facing upstream, anchor down the bottom with some rocks, and then you'll kind of disturb the area in front of the net to collect some creatures. So those are the different types of nets. And then, as I mentioned, just basic tubs can be useful. So you're going to take your samples and put them into the tubs and then identify what you found. It's helpful. We use these sorting sheets. I'm sorry, this one's a little blurry, but essentially it helps. We put little petri dishes on top, full of water on top of each of these different categories. So as we find something in the tub, we'll sort it out and put it into its category on the petri dish. And then that helps us group things for when we fill out our data sheet and identify how many are in each different category. So walking through the process, as I mentioned, we typically sample in a riffle, and you want to approach from downstream, because if you approach from upstream, it could be that you already washed away, you've disturbed and washed away some of the things that you're hoping to collect. So you want to approach from downstream. And then you're going to determine what kind of net is most appropriate. So typically in a bigger stream, the bigger net is useful. So we would typically use the seine. But if you have like a little tiny stream, or maybe that doesn't work very well, you might want to use the D net. And the procedure is you put the bottom of the net along the bottom of the stream. You make sure water doesn't flow over the top backside of the net or under the bottom. And then you're just going to turn over some rocks, rub off what's there, and kind of dig up the area in a little arc in front of the net to get some creatures captured in your net. As I mentioned, you may use a smaller net like a D net, and you might also consider sampling some other areas if you don't have very many riffles, so that you could also look underneath the banks. You can look at pieces of wood that are in the stream, or dead leaves in particular are a great thing to grab for your sample, because lots of things like to hang out on dead leaves. Larger rocks, you may find things clinging to live plants in the stream. Things could be around the edges of the stream. Typically, we are going to disturb the bottom a little bit, so you're going to get into the gravel and the sediment. But as I mentioned, depending on what sort of habitat or how big the stream is, you might want to use the D net. And the bottom line when we're capturing this, in order to do the Global Water Watch Stream Biomonitoring Index, is we want to collect at least 100 individual organisms. So after we use our net to collect the sample, we'll carefully take the net out, try not to lose what's on the net, and then we'll rinse the net into a tub. And then sometimes not everything gets rinsed off, so you want to take a look at your net before you're done with it. And you need to use your fingers or some little pipe or little forceps or a pipette or something to get things off that didn't get rinsed into your tub. And then once you have them in the tub, or a set of tubs, what I found is helpful is depending on the number of volunteers, you typically like maybe 2 people can share a tub or 3. So you want to divide your sample up based on how many people you have that are going through the process. And you don't want to have it be too deep or too muddy in your tubs either, because it makes it hard to see things. Because essentially what you do is once you put it in a tub full of X amount of water, you're kind of looking for things to move. Then you're capturing those things and putting them into categories. And so typically the process would be you'd find something, you get it out of a tub in a spoon or a pipette or something, you identify it, and then you'll put it into a group with other ones that are like that. So you can use ice cube trays. That's kind of a classic way to do it, but we typically use these sorting sheets because we found those to be super helpful. So then once you have you've collected your samples, you've identified them, you've sorted them out, then you're going to record your results and you're going to come up with what's called a biotic index. So this is the Global Water Watch Stream Biomonitoring form. And again, it groups things into group 1, group 2, or group 3. So group 1 is least pollution tolerant, group 3 is the most. So you're going to count up how many individuals are in each taxa, and then you're going to look at how many taxa you find in each group. And the part that you really are wanting is to find a greater diversity of taxa. So in other words, we'll count that you found caddisflies if you found 1 caddisfly or you found 10 caddisflies. We're really looking for kind of the diversity of how many taxa you have. So you will record how many you found. So on the form, like if you found 1 to 3, you'd write an R in there. If you found 4 to 9, you'd write a C for common, and more than 10, you'd write abundant. But you're mainly going to use that for historic purposes, as opposed to calculating your index value. So once you collect this data on the sheet, you want to keep a copy of it. So next time around, you can go, okay, maybe we found caddisflies, but last time we found 10, this time we only found 1. What's different? So then we're going to record the number of taxa. So in other words, let's say that we found in group 1, let's say we found all those things that are listed: caddisfly, mayfly, riffle beetle, snail, stonefly, and water penny beetles. So that would be 6. So we would write 6 under number of taxa. And then as those are group 1, they're weighted more highly. So that would be multiplied by 3 as our partial index value. So the same thing goes for group 2, same thing goes for group 3, but they're weighted to a lesser degree because coming up with a number, kind of an index value for the creek, we're assigning a higher weight to finding things that are not pollution tolerant. So then you add up your results at the bottom and you come up with the total number of taxa, and you also add up your index value. And then based on an index value, you assign a score. And that is the process. So I'm going to just pause for a second and just say, ask, does anybody have any questions on that part of the process that we went through.
I have a question about like time of the year. Like you said that a lot of these live for more than a year.
Uh-huh.
Um, but do you actually see them? Or can I guess yeah, I'm used to seeing bugs on top of this stream like this time of the year, but is this something you could do any time of the year or it's better to do at certain times of the year?
You can do it any time of the year, but the best time to do it is in late summer and early fall. That's when you find the greatest abundance in the Pacific Northwest. So depending on where you are doing it, you may find um, like if you're doing this, say in Alabama, you might find less variability throughout the year compared to here, but that's kind of our, at least from what I've learned from our local authorities, that's sort of our seasonality here is that's when you find the most. Hi, Lori.
Eric, do we also do it and to avoid salmon spawning time of the year too here?
Yeah, that's a great point as well. So, um, and so around here, depending on the creek that you're sampling, you want to learn what that salmon spawning window is for that creek. So, what species of salmon are using that creek and when, and you want to stay out of it during that period. So, so typically around here, you don't want to go too much into October because a lot of things start returning in October, November, December. Good questions. Okay, we're gonna move on and go into the oh, one final note on the Global Water Watch stream biomonitoring is there is a habitat assessment section on the back. So this is a opportunity for you to make some basic observations of what's going on at that site that you're sampling. And it's not part of the scoring, but it's just a way that you can record site changes. So we did do a previous class where we went through a more detailed habitat checklist. So you can either do that instead, or you can do that in addition. Um, but this is just another way that you can record some information about the site.
Okay, I have another question. Is this
Sure.
something you would do like a lot of the monitoring is like it's a good idea to do it once a month, but with this, is this just something you do once a year or how what do you usually do?
Typically once a year. Yeah, typically once a year, like August, September timeframe. Okay, let's talk about BIBI. So, as I mentioned, it's a quantitative method that's used to evaluate and compare the health of the benthic macroinvertebrate communities across streams. So you can compare one stream to another with this. The score is based on 10 metrics, and the score ranges from 0 to 100. And this is kind of the scoring matrix. So from excellent down to very poor. And what's good about this is that this is also used to generate a map. So you can kind of look at what's going on in an area. And actually, another thing that's good about this is that recently King County published a report that actually indicated that um, conditions are getting slightly better in a lot of creeks with regard to this. So that's super positive. Here's an example of the results map. If you go to the Puget Sound Benthos site, you can look at a map that looks like this. So for different organizations that do this type of sampling, they submit their results to this Puget Sound Benthos website, and then the results will be displayed on this map. And you can kind of look at, the key on the bottom of this map showing you kind of very poor to excellent. Most of your excellent sites, they're all kind of in the mountains and forest. And you can see that your pore sites are typically found in the urban areas. So that's just kind of how urbanization affects, as you would expect, more water pollution and more issues for the benthic macroinvertebrates. Okay, as we talked about, best timing is in August and September, but you can go late July through early October. You need to be able to access the site, and it needs to be wadeable, so it can't be too deep. So in other words, it would be really difficult for you to accomplish this like in a river that's deep. It's really best for streams. And you're going to sample a reach of the stream. So that's a particular section of the stream. And typically you'll select 4 different riffles that are separated from each other and by different types of habitat. So that's the ideal sampling method. And then obviously if you're going from stream to stream, you need to decontaminate and clean your gear between streams. So one of the key tools, this is Leora Llewellyn, who taught me and us how to do this because she was doing this for King County. She's using a net called a Cerber sampler. And so that net is got kind of a square opening that's held open by a metal bracket. And it's got a little part that you fold down in the front. And it defines that little bracket, the fold down part is like it's almost like a rectangular hoop. And that defines the area that you're going to sample. So you sample for your 1 square foot sample, you sample that, and you typically disturb it to a certain depth for a certain time. So as I mentioned, the net frame defines the collection area. So you'll take big rocks that are within that collection area and scrub them off, and then you disturb it for 1 minute at a depth of 10 centimeters. And this is us doing that sampling in, I believe, Bear Creek. And then there's 2 methods for BIBI. There's the 3 square foot method or the 8 square foot method. And King County does the 8 square foot method. And so we follow the King County methodology of the 8 square foot method. And you can see where they start downstream. So they collect 2 1 square foot samples in the most downstream riffle. Then they move up, do the same thing, move up, do the same thing. And what happens is that net, or if I go back a couple slides, that net, at the bottom of that net is a cylindrical collection chamber that everything goes into. And then you'll take what you collect in that and pour it into a sample jar where it gets preserved with alcohol. So you can keep going, like if you don't fill your sample jar as you go all the way through up your 8 sites, you only have to do that once, but you may have to take it off and empty it throughout the process of your collection. So as you collect each sample, then you rinse down the sides of the net to get everything, all the bugs into the collection jar. And then you'll empty it into a dish tub. So you're just basically making sure you got everything out of there. And then from that, you'll rinse off things into that. That brass sieve there is a 500 micron sieve. So you're going to rinse off any kind of large rocks that you don't want to send with part of your sample into that so that you get whatever's on that as part of your sample. And then ultimately, once you've got rid of the big rocks and you're just down to this small material that you can put in your jars, then you put it into sample bottles, preserved with alcohol, and you ship it to a lab for analysis. So the part that's kind of an advantage of this is that, professional taxonomist is doing the identification and you get a quantitative score. So this is kind of the definitive method. But I'll say it's really best for, say, agency monitoring in particular. from like a volunteer program standpoint, the other method is actually more fun because you actually get to identify and see the things yourself and come up with an index. And you do come up with you come up with a valuable number as well. And then assuming that everything hasn't died in your petri dishes, which typically they stay alive, you can release them back into the creek. So it's kind of catch and release. So each method has its pros and cons. Lake Forest Park Stream Keepers has been doing this for a long time. And so they have a web page showing how they do it. Once the lab has processed the results, then they get entered into the Puget Sound Benthos website. And then you can look at the data in like a tabular format, or you can look at it in a map format. The map format is easy for you to go, okay, this area has got terrible scores. This area's got good scores. This gets down to more detail. So if you turn your head sideways so you can read what those different categories are, that kind of gives you an idea of all the different sorts of things that are being looked at. And also, when you see a report, you'll get, this is actually a summary because the detail is the detailed report from the taxonomic lab is very, very detailed. So like where it says view samples on the right-hand side, you hit details, then you get into a very detailed breakdown of exactly what it was. But this also helps you see kind of a breakdown of like the overall score. So you can see those just color coded. And then within a number of subcategories, what they found.
So Eric, I
Yeah.
noticed on that report that my creek is just all red. And I guess the assumption is that if we clean up the water, the critters will come back. I guess that's what we're operating from. Am I right?
Well, there's different things that, in general, yes, you're right. And but there's also been some other things that are tried. Like for instance, on Thornton Creek, I'm trying to remember the agency that did it. They actually did a restoration there, but they found that they still had low BIBI scores. And so they actually tried transplanting BIBI from like a reference site that had really high scores there to see if they would take. And I can't recall exactly what the result was of that experiment, but that was just within the last few years that experiment was done. But that's the idea would be, if you presumably if the creek at least still has some stretch where there's some, presence of these communities. I don't know if it's completely polluted from headwaters to mouth. I'm not sure how you would repopulate it with the benthic macroinvertebrates. That's a great question. But in theory, if you remove the pollution and you improve the habitat, that should boost the macroinvertebrate population.
So maybe things like woody debris and leaf litter and stuff like that, maybe that kind of restoration would boost it too.
Mm-hmm. Yeah, because it creates different habitat, but then also, in particular, the part of the food chain that the benthic macroinvertebrates use a lot of is they'll consume leaf litter in particular, and also algae. But they'll consume things, but leaf litter is kind of a key thing. So if you don't have that input, so the more you have of that, like overhanging trees, shrubs, things like that, that also helps out as well. Okay, something to think about once you've done either of these processes is that there are some things that could be spread from watershed to watershed. So one pest of particular significance is the New Zealand mud snail. And we actually were collecting some of these macroinvertebrates for a demonstration for Earth Day. We collected some out of Swamp Creek and took them to an event in Kenmore. And one of our sharp-eyed volunteers actually spotted a New Zealand mud snail in the sample out of Swamp Creek. So I think we have them, at least some element of them, in Swamp Creek as well. But you can see how tiny they are. So, they're like maybe up to 5 millimeters in length, usually less than 6. So there's an example of how small they could be compared with a penny. They have a rightward opening. So I guess if you just look at that shell on the diagram, that's what's considered to be a rightward opening. So if you have it with the pointy end up and the opening down, the opening's on the right. This is a map as of a few years ago where New Zealand mud snails were being found in our local area. And so, the Swamp Creek watershed's right in between North Creek and Lion Creek watersheds, and McAleer Creek. So it's not too surprising they're starting to show up there. So there's a number of different ways that you can decontaminate your gear. So first of all, before you leave the site, you want to clean off anything that's stuck on your boots. So you just want to use water. You can use a water spray, or you can just, you could use some stream water, but you basically just need to try to get stuff off your boots so you're not tracking a lot of material. And then there's some different methods you can do to decontaminate. You can freeze your boots if you have a big, giant freezer with room for dirty boots in it. That might be more difficult for most of us. Soaking them in hot water is an option, but that's still not super easy. The easiest is just to kind of let them air dry. So just clean them thoroughly, let them air dry, maybe dry them in the sun. Just make sure they're thoroughly dry for at least 48 hours before you go to another watershed. What I learned from some local agency people who have to go from watershed to watershed frequently, they use Formula 409, and they have like a little tub, like that tub that those boots are sitting in, that has Formula 409, and they'll put their boots in that so that the base of their boot soaks in that as they're going from site to site, and then they rinse that stuff off before they get in the creek. And they carry like a little garden sprayer for spraying off their boots. And that is it. So I did mention that we're going to be doing some training coming up. And so the training that we have for Global Water Watch Stream Biomonitoring, we're going to do that this coming Saturday at starting at 10 o'clock. And that is going to be at the North Creek site that we've used for other training activities. So I think I emailed that out, but if I did not, if anybody who wants to attend that training, let me know, and I will send you the address for that North Creek training site. And
I thought in the email it said it was moved to August 10th.
There's two different trainings. So one is the Global Water Watch Stream Biomonitoring, and the other is the BIBI. So we have two separate practical trainings.
Okay, so the upcoming one is the BIB, and the one in August 10th is the Global Watcher.
It's the opposite.
Okay, sorry.
That's okay. Yeah. So the one on the 13th is the stream biomonitoring with where you collect and identify the macroinvertebrates yourself. And then the one on August 3rd is the BIBI. And I haven't figured out the site for that yet. So depending on how many people there are and what site we want to sample, I'll pick a location for that one. So to be announced.
Eric,
this-
is the North Creek site the one where we did the stream flow testing?
Yes.
By the oh, okay.
All right. Any final questions? Who's going to come to the training on Saturday? All right, I got a few hands there.
Yeah, do you know if we need to have the gear? What do we need if we want to come? Because I don't have like the boots and everything. So I'm gonna try to get them, go to a store and see where I can find them before the training, but I'm not sure yet. If you have a place of where to look for them, I would love some pointers. But
Oh,
yeah.
sure. That stream probably won't be too deep, in the riffle where we're collecting. So probably a set of tall rubber boots that you could just get at any, sporting goods or hardware store would probably be adequate. Um,
I can bring a pair of boots. I can't go in the water right now anyway, so but I can bring my boots for, is it Sally?
I think
Oh, it was Ronnie.
Ronnie, yeah, if you want to use them.
I will try to go look for it, but I will see if I find it. To see, I don't know what your size, like shoe size and everything, so I'll try to find mine. Yeah, I'm at my feet are small, so that's why I'm asking small number. Usually people, it's too big for me, so I'll try to find. I'll go to like a sporting good or something.
All right.
So can I send you a message? I'll try to do it tomorrow, and if I find any, if I can join or not, is that okay? Or
Sure, that's fine.
okay, thank you.
So for the stream flow and habitat assessment, some of us just wore sandals or tennis shoes. For this, is it better not to? Is there more chance of picking up the New Zealand snails in here, or
No,
like?
it's fine to just, you could also wear like some water shoes or some, water sandals. That would be fine also. You'll just have to check under your foot to make sure you don't have any between your foot and the sandal. Don't have any New Zealand mud snails stuck in between your toes. Okay. Well, thanks everybody, and I'll hopefully see a bunch of you guys on Saturday.
Thank you, Eric.
Okay.